perspective, and the application semantics, which then, given some resources, can do whatever crazy, sophisticated things they might want to do, provided they stick in this model of they launch tasks within, launch computations within the tasks. So it's a different paradigm for resource allocation than I think most people expect. But it's pretty natural, and we as humans do something like this all the time. The best example I can think of is when you're purchasing airfare. You've more or less said, this is the plane, i.e. the data center that I want to run some tasks in. And the airline provider said, okay, well, here are the resources I can provide you at this time. And then you say, well, I want this one. And an extreme version of something like this is Southwest, where you buy your ticket, and then based on some class, you get in some line. And then when you actually are boarding the plane, you pick your seat at that point. So it gives you the ability to say, I would prefer a window seat, but these first 3 window seats are next to crying children, so I'm not going to take those ones. I'm going to take another one. So it gives you a lot of control on the resources that are available of which ones you might actually want to take. And it makes it much, much easier than Southwest having to say, give you a list of all possible ways that you might want to select your seat. Do you care about crying children? Click yes, if so, and then it goes through some crazy process of selecting that. Okay, so I'm going to glance over a bunch of details, but I sort of alluded to the fact that the master is running some code within it that's making this actual allocation decisions, and we call that the allocator. And it's pluggable. It can be organization specific. And you can pick your own policies. I also, applications continuously can provide hints to Mesos as well, which is to say things like, these are racks that I care about, these are data centers that I care about, these are other interests that I have.